I want you to picture something for a second. Um, Imagine you walk into an antique shop way in the back and you find a dusty old crystal ball.
Okay.
But this isn't the kind that tells you winning lottery numbers or who's going to win the Super Bowl next year.
Which would be useful, admittedly.
Oh, incredibly useful. But this one is different. This one shows you the fate of nations. It shows you which global superpowers are going to slowly fade into irrelevance,
Right.
which developing economies are going to explode into dominance, and exactly where the next major geopolitical crisis is going to break out.
That is a very dramatic way to open a discussion on geography. But you know what? You aren't wrong.
I try to add a little flair. But seriously, today we aren't talking about magic. We are talking about something arguably more powerful and definitely more real: demographics.
Yeah, demographics.
We are jumping into a deep dive on the mechanics and metrics of population dynamics, specifically looking at the AP Human Geography source material for topic 2.4.
And honestly, the crystal ball analogy holds up really well. When you understand the mechanics of population, how and why the numbers change, you really can predict the future of global stability.
It's the closest thing we have to a cheat sheet for the next 50 years of history.
Exactly. It really is.
So that is the mission for this deep dive. We need to move beyond just counting heads. I mean, we all know there are billions of people on Earth. That's just a number. We need to figure out the engine driving those numbers.
Right. And to understand that engine, we have to look at the three levers that determine the size and composition of any population on the planet.
The big three.
The big three: fertility, mortality, and migration.
Okay, so births, deaths, and U-Hauls.
Essentially, yes, fertility is the growth engine, people being born. Mortality is the decline factor, people dying. And migration is the wild card, people moving in or out based on economics, politics, or the environment.
Let's start with the first lever then, fertility. Now, digging into the research, I kept running into this term, crude birth rate.
Ah, yes, the CBR.
And I have to say, it sounds a little judgmental, like, oh, that's a very crude birth rate you have there.
It does sound a bit harsh, doesn't it? But crude in this context just means rough or general. The crude birth rate, or CBR, is simply the number of live births per 1,000 people in a population for a given year.
Okay, simple math. If I have a town of 1,000 people and 20 babies are born this year, my CBR is 20.
Precisely. And when we look at this metric spatially across the globe, we see very distinct patterns. In North America, Europe, and other developed regions, the CBR is generally low, somewhere between 10 and 20.
Okay, and looking at the data for North African countries, it's a bit higher.
It's in a transitional phase, usually between 20 and 30. But then if you shift your focus to sub-Saharan Africa, the numbers jump significantly. You see high CBRs consistently over 30.
So on the surface, that seems pretty straightforward. High number means lots of babies, low number means fewer babies. But here's where I got stuck. The research suggests this metric, the crude rate, is actually kind of bad, or at least flawed.
It is flawed. Think about your town of 1,000 people again. You said 1,000 people. Who are those people?
Well, just people. Men, women, kids.
Exactly. That number includes men. It includes grandmothers in their 80s. It includes 5-year-old boys. Can any of those groups give birth?
I mean, biologically speaking, no.
Right. So imagine a retirement community in Florida with 1,000 people. The birth rate is going to be 0. But does that mean the women there are choosing not to have kids?
No.
No. It means the population structure makes having kids impossible. The crude rate dilutes the data because it counts the whole population, not just the people who can actually have babies.
I see. So it's a dull tool. It doesn't tell you why the birth rate is low. It just tells you it is.
Exactly. It's too broad for serious analysis. That is why geographers and demographers prefer a much sharper tool, the total fertility rate, or TFR.
Okay, so help me out here. How is TFR different?
TFR strips away the men, the children, and the elderly. It measures the average number of children a woman is expected to have during her childbearing years, which are statistically defined as ages 15 to 49.
This feels much more personal. Instead of births per 1,000 random people, it's kids per woman.
Is much more predictive. And this brings us to what might be the most important number in this entire stack of research. If you remember one thing from this deep dive, remember this number.
2.1.
2.1, this is the replacement level fertility.
Why the 0.1? Why not just 2? 2 parents, 2 kids to replace them. Done.
In a perfect world, yes. But we don't live in a perfect world. That extra 0.1 is a statistical buffer. It accounts for children who, unfortunately, might not survive to reproductive age. So 2.1 is the magic number to keep a population stable.
So if you are at 2.1, you are treading water. You aren't growing, but you aren't shrinking. But if you drop below that,
You start to contract. And this is where the global contrasts get really fascinating and honestly a little alarming. If we look at Europe right now, the average TFR is roughly 1.6.
whoa, 1.6, that is significantly below replacement.
It is. It means the native population of Europe is effectively shrinking. Every generation is smaller than the one before it. Now compare that to sub-Saharan Africa. The average TFR there is 4.6.
That is a massive difference. You have one continent effectively emptying out and another booming.
And it gets even more extreme. The sources mention a phenomenon called death spiral demographics.
Okay, that sounds like a heavy metal album, but I'm guessing it's bad news for an economy.
It is remarkably difficult to reverse. Look at places like South Korea or Puerto Rico. Their TFRs are so far below replacement level, South Korea is down near 0.7, that they are facing severe population contraction.
0.7, that's not even one kid per woman.
Correct. And think about the implications. It's not just, oh, fewer people. It means schools are closing because there are no students. It means universities are empty. Eventually, it means you have a massive elderly population and a tiny workforce trying to pay for their healthcare and pensions.
The pyramid turns upside down. It sounds like the country is slowly going out of business.
In a demographic sense, yes. The structure of their society is collapsing inward because there simply aren't enough young people coming up to replace the old.
That is a perfect segue to the flip side of the coin. We've talked about coming into the world, now we have to talk about leaving it. Mortality.
Right. And just like birth rates, we have the crude death rate, or CDR deaths per 1,000 people.
Now, I saw a stat here that actually made me feel pretty good about the state of the world. Because usually news is bad, but since 1960, the global death rate has dropped significantly.
It has. In 1960, the global CDR was about 13 per 1,000. Today, it's down to about 8 per 1,000.
That is a huge improvement in a relatively short time.
It is a testament to human progress. Better nutrition, advances in medicine like antibiotics and vaccines, access to clean water. These things have drastically extended life expectancies.
But, and there is always a but, it's not distributed equally, is it?
No, it isn't. And this is where mortality acts as a mirror of society. It reflects the inequality. In developed nations, life expectancy is pushing 80 years. In many developing nations, it's hovering around 50.
That is a 30-year gap. That is an entire generation of life lost just based on where you happen to be born.
And nowhere is that gap more heartbreaking or more telling than in the infant mortality rate, or IMR. This is the number of children who die before their first birthday per 1,000 live births.
I've heard this described as a sort of healthcare report card for a nation. Is that a fair assessment?
That is exactly what it is, because keeping a baby alive through that first year requires a functioning system. It requires prenatal care for the mother, clean water skilled doctors, access to medicine.
Yeah.
A high IMR, which we still see in parts of sub-Saharan Africa, signals a failure of that system. It tells you the infrastructure just isn't there.
So we have the birth numbers and we have the death numbers. Now, logically, if I want to know if a country's growing, I just do the math right. Births minus deaths.
You would think so.
Ah.
That gives you the rate of natural increase, or RNI.
If births exceed deaths, you're growing. If deaths exceed births, you're shrinking. Simple.
In theory, yes. But here's the catch. The RNI excludes migration.
Ah, right. The third lever, the U-Hauls.
Exactly. And this can be very misleading if you aren't careful. You might look at a country like Germany. Their RNI is negative. They have more deaths than births. Based on RNI alone, you would say, oh, Germany's disappearing.
But they clearly aren't. Germany is arguably the powerhouse of Europe.
Right, because they have high immigration.
Yeah.
So a country can have a natural decrease. They are burying more people than they are baptizing, but still grow overall because people are moving into work.
So RNI is really just a measure of the native population's health, not the total number of bodies in the country?
Precisely. Now, conversely, you have the U.S. where the RNI is near zero, pretty stable,
Yeah.
and sub-Saharan Africa where the RNI is very positive.
But numbers on a page are one thing. I want to visualize the speed of this, because 2% growth sounds small, like a bad savings account.
It sounds small, but in demographics, compound interest is a powerful force. Geographers use a concept called doubling time to visualize this. It's the number of years it takes for a population to double at its current rate.
And the comparison in the notes here is honestly mind-blowing.
It really highlights the disparity. Let's look at Nigeria. They have a growth rate of about 2.6%.
Again, doesn't sound like much.
But at that rate, Nigeria's population doubling time is approximately 27 years.
Wait, hold on. 27 years, that's barely a mortgage term. You're telling me that in the time it takes to pay off a house, Nigeria has to build a second Nigeria just to keep up?
When you put it that way, yes. Think about the logistics. Imagine you are the government of Nigeria. In less than 3 decades, you have to build double the amount of housing, double the schools, double the hospitals, create double the jobs.
Just to maintain the current standard of living, not even to improve it.
Exactly. Just to tread water. It's a pressure cooker.
And if you don't,
You have massive youth unemployment, overcrowding resource shortages, and political instability.
now compare that to the United States.
The U.S. growth rate is roughly 0.3%. At that pace, the doubling time is 233 years.
27 years versus 233 years, that is two completely different worlds. One is sprinting a marathon, the other is taking a leisurely Sunday stroll.
And that divergence explains so much about the pressures different regions face. The U.S. is worrying about funding pensions for the elderly, while Nigeria is scrambling to build classrooms for the young.
Okay, so we see what is happening. We have the numbers. But the big question, the one that makes this a true deep dive, is why? Why is Nigeria sprinting while Europe is shrinking? What are the drivers pushing these levers?
It's never just one thing. It's a complex web. We have to look at social, political, economic, and environmental factors.
Let's start with the social side, and specifically looking at the research culture and religion seem to play a huge role.
They do. You have faiths like Roman Catholicism and Islam, which often have doctrines that reject artificial birth control. In regions where these faiths are culturally dominant, you tend to see higher fertility rates. But there is a social factor that is even more powerful than religion: the status and education of women.
Ah, okay. Let's unpack that.
It is the single most consistent correlation in demographics. In societies with traditional gender roles, where a woman's primary expected value is as a mother and homemaker birth rates remain high, she starts having kids young, and she keeps having them.
But when that changed...
When women gain access to education, when they enter the workforce, fertility almost universally drops.
Because of opportunity cost.
Exactly. If you are in school, you delay marriage. If you have a career, you delay your first child. And if you start having kids at 30 instead of 18, you're naturally going to have fewer of them. Education is the most effective contraceptive in history.
That makes sense. So as the developing world educates more women, we should expect those high numbers in Africa to come down.
That is the expectation. But it takes time.
Then you have the government getting involved. I always find it fascinating and a little dystopian when politicians try to engineer population size.
Well, sometimes they feel they have to.
Yeah.
If you are facing that death spiral we talked about, you might implement pro-natalist policies.
Pro-natalist, so pro-birth.
Yes, you literally pay people to have kids. France has done this. Russia has tried it. You offer tax breaks, cheap childcare, long maternity leave, anything to lower the cost of entry for parenthood.
And on the flip side, you have anti-natalist policies,
The most famous example being China's former one-child policy.
which was a massive government intervention to slam the brakes on growth.
And it worked. Perhaps too well. They prevented an estimated 400 million births, but now they are facing a rapidly aging population and a shrinking workforce. It shows the danger of pulling these levers too hard.
It's a delicate balance.
Right.
What about money? Economics has to be a huge driver. I mean, kids are expensive. I saw a stat that raising a kid to 18 costs something like $300,000 now.
Right. In an urban industrial economy, children are an economic liability. They cost money to feed, clothe, and educate, and they don't bring in income,
Versus an agricultural society.
where children are assets. If you are a subsistence farmer in a developing nation, having 6 kids means 6 more workers for the fields. It's your labor force and your retirement plan.
So as countries urbanize, kids go from being farm labor to luxury goods.
To put it bluntly, yes.
Yeah.
And that drives down fertility. But economics is also the primary driver of that third lever. Migration, wealth and jobs are the ultimate pull factors. People move to where the opportunity is.
And finally, the environment. We can't ignore that, especially now.
Unfortunately, environmental factors are increasingly becoming push factors.
Yeah.
Natural disasters, droughts, climate change. These aren't attracting people. They are forcing people to leave.
Yeah.
And they also, sadly, influence mortality rates.
So when we look at all of this together, the birth rates, the death rates, the doubling times the cultural drivers, it really does feel like a blueprint.
That is the best way to think about it. These numbers aren't just abstract math problems for students to solve. They are the blueprint for government planning.
If you ignore the blueprint, your house collapses.
Precisely. If you're in a country with a 27-year doubling time, you need to be pouring concrete for schools yesterday. You need to be modernizing your agriculture to feed twice as many mouths.
And if you are in a country with a shrinking population,
You need to be figuring out how to automate jobs because you won't have enough workers. You need to figure out how to fund health care for a society where there are more retirees than taxpayers.
and for you listening to this, it connects to everything. It explains why your local economy might be struggling to find workers or why global manufacturing is shifting to places like Vietnam or Mexico.
It connects the micro to the macro. It explains why a war in one region or a policy change in another ripples out to affect the price of goods or the stability of borders.
Before we wrap up, I want to go back to that discrepancy we talked about, the 27 years versus the 233 years.
It is the most striking data point we have.
What does that actually mean for the world you and I are going to live in, say, 20 or 30 years from now?
Well, that raises the final, perhaps most uncomfortable question.
Hmm.
We are moving toward a world where the populations of the so-called developed powers, Europe, parts of Asia, North America, are stagnant or shrinking. Their share of the global population is dropping every single year.
Meanwhile,
Meanwhile, the developing world, particularly in Africa, is going to double in size in a single generation. By 2050, 1 in 4 people on Earth will be African.
that is a massive shift in human capital. It's a shift in where the consumers are, where the workers are, and arguably where the innovation will come from.
It is. So here is the question. How will the world order change when the sheer weight of humanity shifts away from the traditional power centers? Is the global infrastructure, political, economic, and physical, ready for that rebalancing?
That's the big unknown.
It is. Because whether we are ready or not, the demographics suggest that shift is inevitable. The math is already written.
A shift that is written in the numbers. And if we want to know what the future looks like, maybe we don't need a crystal ball. We just need to look at the birth rates.
That's the idea.
That is a lot to chew on. Thanks for taking us through the math, the mechanics, and the terrifying realities of doubling time today.
My pleasure.
And thanks to you for taking this deep dive with us. Hopefully you'll look at those population headlines a little differently now. We'll catch you on the next one.